We're going to solve this system of equations using the elimination method. So I need to get rid of the x's in two of these equations. And I'm going to keep it in this middle one here just because that is already a plain x, and that's what I want, no number in front of it. So I'm going to start off by eliminating the x from this top equation. I'm going to do that by adding these two equations together, the first and the second. Now, to cancel out a negative 2x, this would have to be a positive 2x. So multiply this whole equation by 2, and that's what I have right here. Double every single item, and that way you have a positive 2x. And so when you add it to the negative 2x, those will cancel. And then add all the other terms as well. And so then I just came down and wrote what my new first equation looks like. I'm replacing that first equation with the result from our addition. Everything else is the same. So now I need to get rid of the x in that third equation. So negative 8 needs to cancel out with a positive 8. So multiply everything by a positive 8. And you'll get this result here, and then add them together. And again, the x's cancel out. So I came down and wrote what I had here. My new third equation also has the x's canceled out. So that's what I want with the x's. I actually came down, don't need to write my x there. All I did here was just move this middle equation. I moved it to the top, and you can switch the order of your equations if you want. And that's what I did. I just did that for convenience. I like to have my equation with the x to be the top equation. So that's how I'm going to write it. I moved it to the top, and then here's my other two equations. Now, we need to get rid of the y's in two of these equations. So we want this middle equation just to have a 1 here. If we divide everything by 9 in this equation, it will. And so that's all I've done on this step. Coming down here is divide everything by 9 so that you have just a plain y. And now my goal is to cancel out this y and also cancel out this y. So a positive 8, to cancel that out, I'm going to need a negative 8 right there. And that's what I've done here. I've multiplied everything by negative 8. And now I'm going to add those equations together, and the y's will cancel out. And so all I've done now is, here's my new my new first equation, and I write it where my first equation was, and now it has no y's. My second and my third equation have not changed. But now I'm going to cancel out the y here. I'm going to need a negative 65. So multiply everything by negative 65. And so I needed some more space, so this is where we were. We multiply everything by negative 65. And we get that. We add it to that third equation, and the y's cancel out. Here's what we're left with, and that's our new third equation. And now I wanted to divide everything here by 34, so I have just the z. And so that's what I do here. And so we actually have solved for z. Z is equal to 8. And to kind of finalize this, I want to cancel out the z's in both of these equations. 4z here. This is going to need to be a negative 4z. So multiply everything by negative 4. And that's what you get. Add those equations together. The z's cancel out. And so this is your new first equation. And I wrote it there. And you see we solved for x now. X equals 9. And I need to get rid of this z as well. And I actually didn't write this anywhere else separate because we already have a negative z and a positive z. So we just need to add those together. The z's will cancel. When you add these together, you get 5. So our new equation in the middle is going to be it's going to be this, which shows us that y equals 5. And so here's our final result, and we know what x, y, and z are. For number 2, we're finding the matrix product, and since the number of columns here, there's 2 columns, is the same as the number of rows, there's 2 rows, it's possible to find the matrix product. If those numbers weren't exactly the same, then the matrices could not be multiplied. So what you do is you take the first row, and we're going to successively multiply it by every single column one at a time. So that first row is -1 and 3. And so first we're going to multiply it by the first column. So that first item, -1 times 0, and add that to the second number in the row, which is 3, times 1. And -1 times 0 is 0. 3 times 1 is 3. Add those together and you get 3. And that's the first part of your final answer, is 3. And then continue with that same row. I've used red to emphasize that we're using the same two numbers. And move on to the second column. So now we're multiplying by the -2 and the -3. And calculate those results, you get -7. And then again, that same row, the -1 and the 3, and do it by the third column. And calculate those two results, you get 0. And now since we're done with that row, our answers are going to stop being written on the first row, and we're going to start writing our answers in the second row, because now we're using the second row, the 3 and the 6, which I've done these down here in purple. We're going to do the 3 and the 6 times the first column and get our result. The 3 and the 6 times the second column, get our result. And the 3 and the 6 times the third column, and get our result. And this is our final answer. Number 3, we're finding the inverse of this matrix. So you want to start off by writing the matrix, and then right next to it you write the identity matrix. And our goal is going to be to change this side into the identity matrix using row operations, and then what's on this side will be the inverse. And so I'm looking to cancel out these two numbers, change them into zeros to start with, because in this first row I just want a 1 in the top left, so it looks like the identity. So let's cancel out this middle. I'm going to have to add a -1 to cancel out this, and so I'm going to need to multiply everything here by a -1. So that's what I have here, everything in the first row by -1, and add it to the second row. And you do that addition, and here's your new second row. And now I also need to cancel out this value here, change that to a 0. I guess I could point right here, change this value to a 0. So I need to add a -2 to it. So I multiply everything here by a -2, and here's what you get, and add that to that third row, and your result is your new third row. And we've accomplished getting rid of all the numbers in that first column except for a 1 at the very top. So that first column looks correct as the identity matrix. Now we want, for our second column, we want the 1 to be in the middle. Well, if we just flip-flop rows 2 and 3, we'll already have that and it'll look right. So that's what I did at this step, is I just flip-flopped row 2 and 3, and it's looking good now. We actually have the 1s all along the diagonal with zeros below it, so it's starting to look like the identity. In the middle column, we just need to get rid of this 3, which means we add a -3 to it. So multiply everything in this row by a -3, and everything there by a -3 gives you this, and add it to that first row, and your result is the new first row. So now our second column looks correct as well. We just need to fix the third column. So let's start with this -10. We're going to have to add a +10 to it. So multiply everything in this third row by a +10. Here you go. And add it to that first row. And your result's going to be your new first row. So when you add these numbers together, it's your new first row. And the only number incorrect is this 4. We need to add a -4 to it. So multiply everything here by a -4 in the third row. And here's what you would get when multiplying by -4. Add that to the second row. The result of adding these together is your new second row. And so now we have the identity matrix on this side, and this over here is our inverse matrix.